that hidden Markov model HMM post tagging. देखिए यहाँ पे आपने देखा actually why it is called your hidden. Okay, Markov, we know that what are the Markov model, that probability and something statics. Last class में हमने आपको दिखाया था Markov में क्या है, ठीक है. So before digging deep into this HMM hidden Markov post tagging, we must understand the concept that what actually hidden Markov model is. So what actually this hidden Markov model is defined as a doubly embedded stochastic model. ये देखिए stochastic यदि हम आपको नहीं बताते, stochastic मतलब है आपका फ्रीक्वेंसी आप बोल लीजिए, आप प्रोबेबिलिटी बोल लीजिए, ठीक है. सो डबली एम्बेडेड, तो वहां पे क्या था आपको एम्बिगुअस और हमें यहाँ डिसएम्बिगुअस करने के लिए, फॉर दैट हम लोग क्या यूज कर रहे हैं, यदि है तो हम लोग हैंड रिटन टैगर्स यूज कर रहे हैं. सो HMM इज डिफाइंड एज ए डबली एम्बेडेड स्टोकास्टिक रूल. डबली मतलब कुछ तो है, where the underlying stochastic process is hidden. मतलब उसकी जो चीजें हैं, that what will be the working is actually hidden. Okay, we know that this will be the input, this will be the output, but what are the events or what are the things are responsible for getting the input and producing the output. So the hidden stochastic process can only be observed through the another set of stochastic process that produces the sequence of observation. It means that first stage here we have reached, then this. So there is so many processes under this stochastic is there. So number of sequences are there. It will be observed. So what exactly they come out from this? This is, take one example. A sequence word has been used here. Sequence of observation. So here just see a sequence of hidden coin tossing experiment is done, and we see only the observation sequence consisting of head and tail. So it means that whenever we are tossing between two teams or between two individuals, okay. So yes, we have taken the coin and then just tossed it, and then we feel that yes, he lost and he won that toss or some game or whatever. So yeah, chances you can say. That's I have won this chances for toss our selection. Okay. So that is not enough one. Yes, certainly when हमने coin को toss करते हैं, certainly the probability will that it will come head or tail, nothing else. और दो टीम के बीच में या दो इंडिविजुअल के बीच में यही तो है कि टॉस किया, हमने जीत गया, that what we want, this my chance will come. But that is not actually things in there. Lot of things between these two events. Okay. So what exactly this? So the actual detail of this process of the tossing the coin, tossing the coin, how many coins used actually there, and order in which they are selected. किस order में select किए, कितने coins है, are the hidden for us. ये हमसे hidden. ठीक है. अब आप बोलेंगे नहीं. It may be that yes, there is two individual के बीच में एक coin को toss कर दिया, okay. But ऐसा भी तो हो सकता है कि हम if it is a chance, yes, यहाँ तो ये ठीक है कि head और tail आएगा, ठीक है, ठीक है. But यहाँ कि which type of coin you are tossing, okay, 2, 5 and whatever, so 10, 20. So first is that how many coins. दूसरा बात ये है कि एक ही कॉइन को आप टॉस कर रहे हो क्या, मे बी दैट yes, there is a talk between that, yes, we will toss 2 coins, and if it will come both head, then it will be on. So just think over that. यहाँ पे यही कहने का by observing this sequence of head or tail, we can build several HMM to explain the sequence. अभी दिखाएंगे. For example, the hidden Markov model में आपका ये है. This is one state, this is second state, and this you see here. This, then we have self, then this, then we have to come here. So what is the probability of head P1, probability of head P2, probability of tail 1 minus P1, एक बार वेट हो चुका है. Probability of T will be 1 minus P2. ठीक है, ये है. Now we assume that there are two stages are there, okay, in HMM, and each of the stages corresponding the selection of a different biased coin, not based here, biased coin. So following matrix gives the state transition probability. Okay, so what this state probability, this A11, A21, A12, A22. Now, A11, A12, then A21, then A22. Yes. So what it means that A11 क्या है? The probability of transition from one state to another, from 1 to, and A11 plus A12, that is your 1, or A21 or A22 is equal to 1. Yeah, if you have one. And then P1 is your what? Probability of head of the first coin. That is biased of the first coin. Okay, so probability आपका head आने का. Then P2 is the second coin biased of the ये. So we can also create a HMM model using assuming that there are 3 coins or more. यही तो बताना चाह रहा था मैं. So this is why this way we can characterize HMM by the following elements. तो क्या होगा? That n is equal to number of state, जैसा अभी आपने देखा in the model. क्या है? So in the above example we have only 2 state, n equal to 2, only 2 stages are there. Okay, and m is the number of distinct observation. जो आपका था observation can appear with each state in the above example, जो आपने देखा था head और tail आने के. ठीक है, distinct observation. Then A is the state of transition probability distribution, that is your matrix जो आपने देखा था, matrix A in the above example. Here is A. Then we have P is the probability distribution of the observable symbols in each state. In our state that P1 and P2 we use. Okay, and then 1 is your initial state distribution. We have to start from our state. Okay. So use of HMM for post tagging क्या है? The process for finding the sequence of tags in which most likely to be generated. इसीलिए हम लोग HMM को use करते हैं with these all characteristics. So we can model this POS process by using the HMM where tags are hidden state that produced the observable output, that is your words, head array, tail array, whatever. So mathematically the post tagging we also interested to find the tag for the sequence, that is your count which maximizes. So probability of count of that word. So आपने देखा होगा n gram, 2 gram और इसमें 1 gram, 2 gram और n gram में number of counts are there, C1, C2, C3, number of words are there, W1, W2, बस वही पे ये सेम चीज यहाँ पे आपको अप्लाई करेंगे. ठीक है। सो इसके लिए आपका क्या है, वन ऑफ द दैट वेयर वी हैव टू यूज इट, that on other side of the point faces that is we need a lot of statistical data to reasonably estimate such different kind of such kind of sequences जो भी आ रहे हैं. So however to simplify the problem we can apply some mathematical transformation with some assumptions are there. So post tagging is the special for the Bayesian interface, and we will start this by starting the problem with the Bayes theorem या Bayes rules by using some. तो ये आप हमने पहले भी आपको दिखाया था, probability of this and this, then count of this multiplied by this W of then this one. Divided by multiplied by this and then divided by probability of that words. So ये आपका mathematically जो है सो आपको present हम लोग कर रहे हैं. So we can estimate the denominator in all these cases because we are interested in finding the sequence of count which minimize the above values. So there is no effect in our answer that we have to just put in this will be 1. Okay, then this. So we reduce the problem in the above expression and this, and we require a large amount of data here, and reasonably independence, assuming about the two probabilities in the above expression to overcome with the problem. So we have here that is your two assumptions are basically there. We have used some assumptions. Okay, assumptions are there. So first assumption is the probability of tag depends on the various 1 gram आप बोलिए तो 1 gram that is your what bigram model, previous 2 that is your trigram, okay, then previous n tag that is your n gram model. So mathematically we can explain that the probability of this C1 up to that T and then this by product of this I equal to 1 से लेके n तक and then probability of this for n gram. Okay, बाईग्राम के लिए आपका ये यूज हुआ है, ठीक है. अब जो जिस ग्राम का आपको यूज करना है वो आप यूज कर सकते हैं. फर्स्ट. सेकंड है that we have in the equation 1, what it is in equation 1. One in the above estimate the assuming of the word appearing in a category independent of word in the previous or that successfully succeeding categories, which can be explained mathematically by this. So basically the count of that will come the product of this and the probability of W by Wn. So here now this base has two assumptions that our goal reduces to find the sequence of count which is the maximum. Okay, so here this. Okay, and likewise, and last but not least we have to use some of the special instances character symbols for that. तो हम लोग वो आप यूज करेंगे. सो यहाँ पे बेसिकली आपका HMM का कॉन्सेप्ट ये है कि हम किस तरीके से आपका जो है सो काउंट ऑफ वर्ड और HMM में जो और भी इवेंट्स हैं वो उसकी प्रोबेबिलिटी को फाइंड करने के लिए आपका व्हाट आर द स्पेशल थिंग्स आर देयर, उसी में हम लोग क्या है आपका बेसियन और ये चीज़ों को यूज करके हम जो भी सीक्वेंसेस हैं वो फाइंड करने की कोशिश करते हैं.